which are now much milder, they, when you first let the clutch out, for the first sort of 10 to 25 feet, they will slip like fuck, according to how many shims you put behind them.
Right.
So what that means is you can launch the bike at like 7,000 RPM, and then by adjusting individually the springs in the back of here, you can then get the second stage to come in wherever you want it.
Yeah.
By balancing the spring against the weight there.
I see. So it's just basically the springs then doing the work.
Yeah,
and the weights.
The variation that you put into the spring, and then the weight for the final lock-up.
So that's a plate behind it. Is it like a friction plate?
That's the original pressure plate.
The pressure plate.
With all the standard clutch. Well, it's not a standard clutch. Normally it's a 9-plate clutch. I've got a 10-plate Kevlar clutch in it.
Right.
The only added bit is this.
Yeah.
So you remove the springs, you put this in, and it, well, takes over the management.
Right.
And the other thing that's happening here is we put in a sensor through there. That rain?
Yeah, it was raining earlier as well.
Putting a sensor through there, a magnet onto there,
yeah,
and put that sensor through there, which will measure the speed. I've actually printed you some material so you can read up on this. It explains it very well, and the power of this setup is ridiculous.
Yeah.
We'll have more data than any man. You could spend 7 days a week, won't analyse it. It's just fucking radical. So that senses that, which tells you how much the clutch is slipping, yeah, against engine RPM.
I see, yeah.
Then we're also monitoring rear wheel speed and front wheel speed. So we know whether the clutch is slipping, whether the back wheel is spinning, and you can actually count the revolutions that it spins at a given point, or whether the front wheel's off the ground. So you can tell exactly, you know.
Exactly, yeah. There's no
even if the front wheel's just doing that and hesitating in its turn, it'll tell us. So we should be able to balance this thing up so that you can literally drop the clutch at 7,000-8,000 RPM and take off like a fucking rocket.
Yeah.
With the minimum wheelie. I mean, the perfect run, your front wheel would be 5 mil off the deck for the first half of the run. It wouldn't turn. When you get halfway down the run, it'll start spinning.
Surely because there's no friction on there, that will take a little bit of a spin, won't it? But it'll just stay at that spin.
Yeah, it'll be so slow, it'll be obvious that it's
not moving.
Because the mile per hour is read off that as well.
Yeah. All right.
I mean, the idea is to keep it as little wheel spin, as little front wheel lift, and the maximum amount of power you can push through the clutch and maintain those two conditions throughout the run.
Yeah.
That's the ideal situation.